Hello students, welcome to GOVidya. So in our 500 important question series, so we are discussing different subjects and with some explanations also. So from these sessions we'll understand the power system subject. Okay, so as usual I will start with power generating concepts. After that we'll go for the transmission and distribution, then we'll go for the analysis part, then power system protection. Okay, so in this order only we will discuss, and mostly the questions will be from so this transmission and distribution and power system analysis. Okay, we'll spend more time on this, and remaining subjects or remaining topics we can spend a little bit less time. Okay, so and you can understand. Okay, so these are only for the revisions, and I have given here so many important model questions, and I will add some of the explanations also here, so it will boost your revisions. Okay, so when you have to listen these classes, whenever you have off time, okay, so like for example when you are studying, so at that time if you get some break or if you want some revisions, okay, so you can prefer this kind of classes. And I'm telling you, okay, so with all these 500 question series, or we may add some of the questions extra also. Okay, you will get complete revision and it will boost your preparation definitely. Okay, so anyhow let's go into the questions. Okay, so first question: arrange the following in the correct sequence in which the flue gases passes through them after coming out of the boiler in a thermal power station. ID fan, air preheater, economizer, electrostatic precipitator. Select the correct answer using the codes given below. Okay, so codes they have given the sequence. Okay, see one thing I want to mention. Okay, so some of the tips for examinations also, how we have to read the question also, so important for these examinations, because there will be limited time for each and every question. That's why we need to read every question only one time. Okay, so when you are studying, read that when you are reading the question, read that question properly. Okay, so see how I have read. So I have started and I have completed the question. Okay, you should not read it like speed or slow. Okay, so you have to find out what is the optimal speed for each and every question. Okay, so first we have to read, and whenever you are reading the question you have to understand completely. Okay, so that's how you need to read. Okay, so otherwise there is no point reading in second time. Okay, so if you are starting fast and again you are reading for the second time, means that will be waste of time in examination. Okay, so remember this point, and it will be useful for each and every question of you. Okay, so then anyhow what they have asked: arrange the following in the correct sequence in which the flue gases passes through them, okay, after coming out of the boiler. Okay, in a thermal power station they are asking different components they have given, and they are asking what is the sequence of flue gases in these components. Okay, so you can observe what is the concept we are having from a boiler. Okay, so what we are doing inside the boiler, we are adding coal. Okay, after that we are adding some water into this one, not mixing with the coal. Okay, so coal will be separate and water will be separate, and for the proper combustion, okay, so we are taking air also. Okay, so three things we are taking. Okay, so how many inputs will be there? Three inputs will be there. Okay, if you observe our schematic, coal will be taken from this side. Okay, so coal will be taken from this side, and it will be two types of boilers here. One is water tube boilers, another one is fire tube boilers. Okay, water tube boilers means inside the pipes there will be water, and fire tube boilers means so inside the pipes will be having the coal and it will burn. Okay, so the combustion process we will do inside the pipes or inside that vessels, then it will be called as fire tube boilers. Okay, so anyhow, so these are two types of boilers. So somehow we are doing in this one. Okay, so what is the outcome of this one? So the first thing is steam. Okay, so steam is the outcome. Okay, so steam is the outcome. Okay, so and before that only, okay, so coal we have taken, steam has to come. Okay, so how steam will come? Okay, so from the coal it is not possible, right? Okay, so we need to send water only can convert into steam. That's why from your nearest pond or river we have to take the water. Okay, so directly we are not taking this water, so we have to demineralize that water. After that we have to increase some pressure and temperature, so low pressure heaters, high pressure heaters will be there. After that only we can send into this one. Okay, so through what we can send the water? So through the economizer we will send the water. Okay, so this component is called economizer. Okay, so economizer. Okay, so and the steam we have produced right already. Okay, so this steam has to go. Okay, so has to go to the turbine. Okay, so steam turbine it should go. Okay, so that's why what we are doing, it has to go to the steam turbine, but it should not lose any temperature and pressure. Okay, so it should increase the temperature, then there will be better output for us. Okay, so better heat efficiency will be there for us. Okay, so that's why we are giving a superheater. Okay, superheater for this. Okay, so then heat that whatever steam is there, okay, so its temperature will be maintained high and it will go to the, so whatever we are having here, so the entire components. Okay, so like turbine will be there, which is steam turbine. After that we will be having our generator. Okay, so after that condensers will be there. Okay, so I'm not going into this part. Okay, so leave it now. Okay, superheater will be there and economizer will be there here, and air also we have to take inside. Okay, so air also we have to take inside. That's why we need air preheater. Okay, why air preheater required? Directly air we can take inside, right? So directly if you take air inside, air will be having some moisture content, some of the unwanted quantities. Okay, some particles will be there also in this one. Okay, so moisture will be there definitely. Okay, so that's why if you send into this one, okay, so the combustion process will not be proper. That's why we are using air preheater. Okay, so air preheater. Okay, so these are the three things first we have used. Okay, so first one is coal input, second one is water. Okay, so water we have taken either from river or from a pond. Okay, so anything, and third one is air. Okay, so like this three we have taken inside, and flue gases will come out after the combustion. So generally, okay, so there will be two types of outcomes from this here also. Okay, so one is the bottom ash, another one is fly ash. Okay, bottom ash means which is having more weight and it will come as a deposits. Okay, so it will be considered as the bottom ash. Another one is fly ash. Okay, so fly ash means it will be having very less weight, so it will fly always. Okay, so those things we have to collect and we have to send through some pipes, through this superheater, economizer, air preheater, then after some other components. Okay, so anyhow, why we are sending this flue gases into these things? That means we are not mixing with the steam. Okay, so the steam pipe will be like this, and so the pipe, okay, so remaining, so this flue gases will be coming like this, and it is increasing its temperature. Okay, steam temperature will be increased here. So that means high temperature flue gases, we are utilizing its steam, its heat. Okay, so that heat we are using to increase the temperature of steam, to increase the temperature of water, to increase the temperature of air. So like that, it is like just a feedback path only. Okay, heat feedback path we can call this one. Okay, so and one more thing you remember, in all these three, okay, so which is more important for us? Okay, so here steam is going in this one. Okay, here water is going like this, here air is going like this. Okay, so in all these three, which is more important for us to improve the efficiency means the steam only. Okay, so that's why steam will be direct component which is losing the, which can lose the temperature which is very fast. Okay, so that's why what we are doing, the temperature of steam we are increasing first. After that, the temperature of water we are increasing. After that, temperature of air we are increasing. Okay, in this order we are increasing. So that flue gases will flow in this order only. Okay, so flue gases will flow in this order only. Okay, so after air preheater, we will be having electrostatic precipitator. Okay, so ESP, which is electrostatic precipitator. So in the flue gases, there will be so many components which are very, very dangerous, and once these are out, so we will be getting some of the skin allergies. Okay, so all these problems to the nearby areas. Okay, we should not release those things to the atmosphere. Okay, so that's why electrostatic precipitator must be there. Okay, so after this, all it will collect all the precipitate, so that also we need to dump inside the deep oceans only. Okay, and this whatever bottom ash is also there, this also we have to dump inside the deep oceans only. Okay, there are certain methods for these things. Okay, so leave it for this question. So anyhow, next we need to use fan. Okay, so ID fan we have to use to send that whatever remaining smoke is there. Okay, after collecting all these flue gases, only smoke will be available. Okay, so that smoke has to send out. Okay, if you release directly, okay, so what will happen? It will spread at the nearest to the earth's surface only. Okay, we have to send little bit up. That's why we need to use this induced draft fan. Okay, so whenever you want to send something from in to out, okay, so it will be like ID fans we have to use. Okay, if you are using some fan, okay, from outside to inside, okay, some flow must come from outside to inside. It must be a water or air or some other component. Okay, so we have to call those as forced draft fans. Okay, you can observe near to the air preheater we will be using FD fan. Okay, so FD fan. Okay, here FD fans we will use. Why we are using forced draft fans here? so we have to take inside some component. That's why we are using forced draught fan. Okay, so here ID fan we are using. Okay, so then it will go through the chimney. Okay, so through the chimney, and you can observe chimney, how is this structure. Okay, so if we will send, and the structure area of cross section is decreasing, so it can go for higher heights. Okay, so more height it will flow, more height the smoke will be released, and it will go like this. Okay, so this is what smoke position. Okay, so like this smoke will go. Okay, so whichever direction airflow is there, that direction it will flow, so it will not harm any of the so living ecosystem here. Okay, so that's what the idea. That's why ID fan is required. Okay, so now what is the question they have asked? Order. Okay, so in the which order the flue gases will flow. Okay, so in all these things you observe, first superheater is not there in this. Next economizer is there. Okay, so next air preheater 3 2. Okay, so next electrostatic precipitator, then ID fan, so then chimney will be there. Okay, so here chimney is not there in options. Anyhow, totally we can get all the sequence. Okay, flue gases will generate in the boiler. Flue gases first will enter superheater, because in this steam is there. Next economizer, in this water is there. Okay, so next air preheater, in this air will be there. Okay, why you are heating? Because there should not be any moisture. Okay, if you take air inside, atmospheric air, so then there will be some moisture. If you heat, all the moisture will be gone. Okay, combustion will be proper if you send a hot air. Okay, so that's why we have sent hot air inside. Okay, and after that electrostatic precipitator and induced draught fan. Okay, so then chimney. Okay, so in this order total 6 components are facing this. Okay, 6 major components are facing this flue gases. Okay, so anyhow these flue gases will be having all the inert gases. Okay, so these inert gases are very very dangerous, so to the living organisms, anything. Okay, so that's why, so we should not send that flue gases into the atmosphere. That's why we have done all these electrostatic precipitation concepts. Okay, so and at present, okay, so in Telangana you can observe. Okay, so electrostatic precipitators in the new power plants. Okay, so they have increased the norms. The efficiency of this electrostatic precipitator will be around 99%. Okay, so 99%, and we need to improve it to so near to 100%. Okay, so that's what other countries like UK, okay, so these all countries, okay, Europe countries, some of the countries they are doing like this. So that's what we are adapting into India also. Okay, so that's why recently you can observe one of the power plant. Okay, so recently opened in Telangana. Okay, so the because of electrostatic precipitator modifications only, they have taken almost 2000 crores extra budget again, and they have finished that project. Okay, so in the last stage it is having now. Okay, so anyhow, so this is the order we have to follow. Okay, and from this question what we can understand, so we need to know the schematic completely. Okay, so what are the components are there, and most of the questions from this thermal power plant, how they will be asking, so based on the components only they will be asking the questions. Okay, so that's why when you are concentrating this, schematic should be in your mind. Okay, so not only this area. Okay, so after this there will be some valve will be there. Okay, so after the valve, so there will be turbine. Okay, so what kind of turbine? Steam turbine we have to use. And how many stages of turbines we will be having here? Three stages turbine we will be using. Okay, first high pressure turbine, then intermediate pressure turbine, then low pressure turbines. Okay, so anyhow you might have learned already that in the classes. So after that we'll be having this condenser under this one. Okay, so and our synchronous generator, what kind of generator we are using, and what are the electrical equipments available after that. So then after the condenser we will be having cooling tower, and how a feedback path will be working. Okay, so where it will be connected. Okay, so and similarly ash handling plant will be there. Okay, this is the bottom ash handling plant, and ash dumps will be there. Coal handling plant will be there. Before that there is the pulverization. Okay, so and there are some process before that, that also we need to understand. Okay, so this is all completely the thermal power plant. Okay, so see from this question we can understand complete thermal power plant analysis. Okay, so that's why I have taken this question. Okay, so next question, consider the following statements regarding pumped storage plants. First statement, a pumped storage plant is a base load plant. The starting time of a pumped storage plant is very short. Reversible turbines and pumps are highly suitable for pumped storage plants. Okay, which of the statements given above are correct? Okay, so they are asking which statements are correct in this one. Okay, so remember only one time you have to read the question. Okay, so that's why you have to read it slowly and sufficient speed we have to maintain. Okay, so consider the following statement regarding pumped storage plants they are asking. Okay, so first of all we need to know what is a pumped storage plant. So anyhow you might have know already. Okay, so this is hydroelectric power plant only. Okay, so there are three types of hydroelectric power plants. Okay, pumped storage plant. Okay, so what is pumped storage? Pumped storage. Okay, so that means storage definitely required, right? Okay, so I will tell you one thing. See, whenever there is a river flow, okay, so river flow, so we need water for the generation. Okay, in a hydroelectric power station we need water for the power generation. Okay, so we'll construct a dam and we'll stop that water. Why we have to stop the water? If water is continuously flowing, can you construct the dam here? We cannot construct. Okay, so that means if the water is not flowing continuously, only 2 months in a year or only 3 months in a year, just like our rivers in Telangana and Andhra Pradesh, you observe. Okay, Penna river is there. Okay, Krishna river is there, Tungabhadra river is there. Okay, so Godavari river is there. Godavari is a little bit higher flow rate is there compared to remaining rivers. Okay, these are the major rivers we are having, and its tributaries also there. Okay, so anyhow, so in these rivers, okay, so you just observe only 3 months or 4 months water availability will be there. Okay, so that means we cannot generate the electricity, we cannot produce the power every time. Okay, so that means we have to stop the water, so then only we can generate whenever you want. Okay, so that means we have to construct a dam. Okay, we have constructed the dam. Okay, for example this year we are getting some drought. Okay, so that means no much rain we are having, so that means no much water also we cannot store here. So at that time what happens? Whenever you have to use this water, use that water, but it must release to the downside of the river. But instead of releasing to the downside of the river, we'll have another pond here, another small dam here. Okay, so whatever used water will come here, that will be stored, and this water we have to pump back to the main pond, okay, or main dam. So again we can use that water. There will be some loss of water. Okay, so that continuously we cannot use this water. Okay, so there will be some loss. Whenever it's required we have to generate, whenever it's not required to generate, then we have to send back this one. Okay, so that's what pumped storage plant. So now what they are saying, a pumped storage plant is base load plant. Base load. Okay, first of all, what is a base load? Base load means, see, continuously which load is available. Okay, continuously which load is available, that kind of load is called base load. Okay, so for example in a room, okay, so in a room, okay, so for this room I will consider. Okay, so every time I need one fan and one light. Okay, every time I need one fan and one light. Okay, so that's a full day. Okay, full day I need one fan, one light. That will be my base load. Sometimes I will use one extra light, that will be only whenever I required. Okay, then only I will use that. Okay, only for that 1 hour or like that. I need AC only for 2 hours. Okay, so only in the afternoons I will use AC. Okay, so that means that will be our peak load. Okay, so what is the base load? Only that every time availability load is there. Okay, that is called base load. Okay, so for example if you consider this car, okay, so you observe load curve. Okay, so for example like this one load curve is there. Okay, you observe what is the base load means, continuously this much load is required. Understanding, this much power generation, it is in terms of megawatts. Okay, so this is in terms of hours we'll consider. Okay, so this much of megawatts, any time this much of megawatts is required. Understanding? Okay, so that means this will be called as this much of load. For example this is 100 megawatt. Okay, so this will be our base load. Understanding, every time this much of load is there, every time this much of load is there on a power generating power system. Okay, so then this much of power we have to generate, right? Can you use this pumped storage plant to give this 100 megawatt? You observe, okay, to give this 100 megawatt full day we have to run. Okay, so this power plant, can we run this power plant for full day? Okay, 24 hours if we are running continuously, water will be using, and with some buckets we have to pour that water again. Okay, it's not possible. Okay, so there will be loss of water also, right? Okay, so that's why we cannot use a pumped storage plant as our base load power plant. When we have to use, whenever it reaches the maximum peaks, okay, so in this area only, like our demand has increased more than 200, okay, so 220, like that, it is near to the almost maximum value, okay. We will be having old data also, okay, we have to use this water now. Understanding, okay. So whenever it's increasing, okay, so what we will use the same base loads only, okay, same power plants only. Increased capacity we will use little bit. Again, whenever it's increasing more, we will use hydroelectric power plants only, okay, but not pumped storage plants, okay. Hydroelectric power plants with a big dam, okay, so we will release that water to the next power plant, that's it, okay. And after that only we will be using pumped storage plants. Understanding, okay. So here you might have know already, right, okay. So three power plants we are having, okay. In a hydroelectric power plant, three types will be having, okay. So first one is runoff river with pondage, okay, with pondage. Second one is runoff river without pondage. Third one is runoff river without pondage, that too as a pumped storage plant, okay. We can simply call as pumped storage plant, okay. See, what is this runoff river, okay. So many students may confuse this terminology, okay. Runoff river, okay, so runoff, that means flow of river with pondage. Pondage means stoppage, okay. So pondage, or we can consider as a dam, okay. So a dam we can consider. Runoff river with pondage means with dam, okay. So dam. So here dam means big construction only, okay. So next, second one is runoff river, that means flow of river without any dam, okay, or without any pondage, okay. That is the second type, okay. So third one is pumped storage. Pumped storage means there will be some main dam and there will be some tail dam, okay. So tail pond, main pond, okay. So like that we can call, okay. So these are the three types we are having. So here what we can use, we have to use it as a base load or peak load, we need to know, okay. For example, in a river continuously water flow is there, okay, continuously water flow is there. That kind of power plant we can consider, okay, that kind of hydroelectric power plant we can consider as the base load only, okay. So why base load? Hydroelectric power plant, how we can use as base load? Because water is continuously flowing, okay. We cannot construct big dam. If you try to stop that water continuously flowing river, okay, so what is happening? Then all these villages will get the floods. Not only nearby villages, okay, so all this dam also will be damaged and the next villages also will be getting floods. Understanding, okay. So that's why we should not construct a big dam, okay. So on runoff river or continuously flowing river, continuously means all the year, okay, it will flow. Water availability is sufficient, every time water is available means no need to construct the dam. That means we cannot construct the dam, water flow is available, we cannot stop with the dam also, okay. What happens? Then we have to use that water continuously. That's what the solution, right, okay. Otherwise what happens? Then all this water will be wasted, it will go to the oceans only, okay. So that's why we cannot stop with the big dam, we have to construct a small dam, okay. Generally we will call it as a check dam, okay. So in villages we will call it as check dam, okay. So anyhow, so we cannot stop with the big dam and we have to use that water means continuously we have to use, okay. So that means in this base load only we have to use. This is called base load, this is called peak load, okay. So in this base load only all that generation must complete, every time generating, we can generate every time because water is continuously coming, right, okay. So that means hydroelectric power plant without any stoppage, okay. Hydroelectric power plant, okay, which is having not a big dam, okay, or only small check dam is there, that will be used as our base load power plant, okay. So this is the conclusion, okay. And one more thing you remember, okay, so the same terminology will be used, runoff river without pondage, okay. Runoff river without pondage will be used as our base load power plant, okay. So for example, okay, so only 2 months or 3 months is there, okay. So then what you have to do? You have to stop that water. So what you have to do? Stop the water means we cannot use that water every time. Understanding, okay. And we cannot use that water every time means somehow we have to increase the power output, okay. So generally power output will be proportional to discharge and similarly head, okay. So these two, and the big formula is there, okay. So no need to remember now, okay. So later in a different question we can understand that, okay. So here power output, electrical power output from a hydroelectric power plant, we can use Q is the discharge and it is head. Okay, what is the head? Here many students may confuse what is the head. Okay, see, height and head both are different. Okay, so for example, from a sea level, a point which is at a certain meters. Okay, so this will be like height. Understanding? Okay, what is the head means? The point of release of water to the point of contact with the turbine. Okay, water turbine, that is called head. Understanding? Okay, you may consider, okay, so both will be same thing, right sir? Okay, but you observe one thing. Okay, so to increase the head of the thing, okay, height you cannot increase. Okay, height we cannot change. A point is kept at some at certain point. Okay, like at a certain meters, the height will be fixed, but head can be changed. Okay, how we can change the head? If you increase the dam height, okay, so then head will be increased. Otherwise, to increase the head, what is the thing? Decrease the height of this turbine. Okay, instead of keeping at surface level, okay, we have to keep underground. Okay, so 2 more floors down. Okay, or 3 more floors down. Okay, if you know about the Srisailam power plant, okay, so we have 2 plants in Srisailam. Okay, one will be considered as the AP one, another one is the Telangana one. Okay, so anyhow, you observe there. Okay, so what will be there? So the turbine will be going to the downside of sea level. Okay, so that means instead of increasing the dam height, we are decreasing the turbine height. Okay, that means negative height we are making for that. Okay, so that's why the head will be increased for that, so power output will be increased, head will be but why we have did this? Because we don't have much discharge. Okay, so more water we cannot use now, so that's why we have increased the head there. Okay, for example, continuously flowing river is there, more water availability will be there, no need of that much head. Understanding? No need of that much head. Continuously flowing river is there, that means more discharge, more water availability is there. Okay, so we can utilize that water properly, and no need of much head. That's why no need to construct a big dam. Okay, small dam is enough, sufficient head is enough. Understanding? Okay, so based on this we can understand. Okay, so there are 2 types of hydroelectric power plants are designed based on this. Okay, so if it is runoff river with pondage means head will be more, discharge will be less. Okay, runoff river without pondage means discharge will be more and head will be less. Okay, so like this we can understand. And what is this pumped storage plant? For the pumped storage plant also there is no water, right? It will also having higher head only. Okay, and higher head means that water again we have to put back, means we need some pump to put back that water. So what we will do generally? Okay, so here what are our operations? This water we have to use to generate the electricity and we have to store that water there. And whenever there is, we are not generating at that time, okay, this water we have to put back here. That means total 4 components are required. Okay, so first one is turbine, water turbine is required. Okay, after that generator required. Okay, so to generate the electricity. Now to pump this one, okay, one water pump is required, another one is motor required for this. Okay, to run that pump we need a motor. Okay, so these 2 are required. That means total 4 components are required. Instead of using these 4 components, we have made it as only 2 components. Okay, so one will be reversible turbine, another one will be a synchronous generator cum motor. Okay, so that's what we will call it as synchronous condenser also. Okay, because it's giving some of the reactive power compensation, we are calling it as synchronous condenser. Okay, so anyhow, so you observe instead of using 4 different components, we are making it as 2 components only. Okay, so you observe the options here. Pumped storage plant is base load plant, never possible. Okay, so base load plant we cannot use. Okay, so we have 3 different and one is base load power plant, remaining 2 are peak load power plants. Okay, so the starting time of pumped storage plants is very short, that's why we are using it as peak load power plants also. Okay, so it will be like less than 4 minutes. Okay, 4 minutes and 5 minutes. Okay, so that will be the time. So whenever load increased, immediately we can respond within 5 minutes only, we can do that schedule of power supply. Okay, so anyhow, this is a correct statement. Reversible turbines and pumps are highly suitable for pumped storage plants. So this is what we have discussed now. Reversible turbines and pumps. turbines also reversible and pumps also reversible, they are saying. Okay, so anyhow it will be reversible turbines, and so they should use as generator and motor. Okay, so anyhow this statement is also correct. Okay, so you observe what are the option 2 and 3 are correct for this one. Okay, so anyhow this is one of the important models about base loads and peak loads. Okay, so anyhow some of the other power plants also there. Okay, we can compare. Okay, remaining power plants also in the next question. So which of the following power stations is mainly used to cover peak load on the system? Okay, so peak load. So just now we have discussed what is the peak load, and just see this one. Okay, so coal based thermal power plant. Okay, so here I will tell you how much time we need to operate this one. Okay, so here coal based thermal power plant, so we'll be taking 8 hours completely. Okay, so 8 hours to start this one. Okay, completely from a completely shut down plant. Okay, that means we have completely stopped the generation. Now if you want to start the generation, it will take at least 8 hours. Okay, so generally recent power plants like super thermal power plants are there, they are taking almost 6 hours only. Okay, you consider it as 8 hours at present. Okay, so next nuclear power plant. Okay, so this also we need to build this. Okay, so steam, that's why it's also will take around 8 hours. Okay, so we can even advancements also are there in this one. Okay, so we can reduce this 8 hours to 6 hours also. So at present you consider it as 8 hours. Okay, gas based thermal power plant. Okay, gas based thermal power plant. See, many can consider this is gas turbine power plant. This is not a gas turbine power plant. Okay, gas based thermal power plant. Okay, so it's also a thermal power plant. Instead of using a coal as the input, we are using gas as the input. Okay, so that's why, so this will also take, okay, almost similar time only. Okay, like 6 to 8 hours it will take. Consider it as 8 hours. Okay, then pumped storage hydroelectric power plant, which will take only 4 minutes to start. Okay, so that's why whenever peak load is there, okay, peak load on the system is there, pumped storage plant only we have to use. Okay, there are reasons for this. Okay, so why they are taking more time. Okay, and here we have to discuss about, so this 8 hours, what we will do in this 8 hours. Okay, any plant. Okay, in this any plant, what we will do in this 8 hours. Okay, let's consider about this thermal power plant. Okay, so thermal power plant. Okay, so in the thermal power plant, so there are 3 types of reserve we can consider. Okay, so thermal power plant, let's consider one power plant is having 400 megawatt. Okay, another power plant which is thermal power plant only. Okay, all are thermal power plants, also having 400 megawatt. Okay, 400 megawatt. Okay, so and another power plant is also having 400 megawatt. Okay, and this is completely shut down. Okay, so first type of plant is completely shut down. Okay, so completely shut down means first we have to send the coal and we have to build the turbine, we have to build the this boiler. After the boiler, turbine also need to be ready, everything ready. After that only we can start the generation. Okay, so water we have to collect, all this process is there. So this is completely shut down means it will take 8 hours. Okay, so for example, another power plant is there which is also having a 400 megawatt, and it's already boiler prepared. Okay, boiler is ready to accept the inputs. Okay, so at that time, that means we have already made the boiler ready, and we have to start the generation. Okay, so that means initially we will not get that much of steam pressure and temperature. Okay, so that's why, so it will take at least 3 to 4 hours. Okay, so to start the generation, because we need that pressure building and temperature building. Okay, and another one is there, already it is giving a 200 megawatt supply. Now if any load increased, we can add immediately. Understanding? Okay, this will take only like 15 minutes only. Understanding? Okay, so this is also thermal power plant. This is also thermal power plant. This is also thermal power plant only. Okay, so you can observe one thing, this kind of power plant which is completely shut down. Okay, so it will take 8 hours to start. This kind of reserve, this is 400 megawatt of reserve we are having. We can generate this, but not ready immediately. It will come after 8 hours only. Okay, so this kind of reserve is called, okay, cold reserve. Okay, cold reserve. So next, this kind of reserve, okay, this kind of reserve is called, already boiler is prepared, but temperatures we could not build immediately, okay. Superheaters need to work and our DM plants need to work. Water has to accept, okay. So for this building of temperature and pressure, it will take at least 3 to 4 hours. This kind of reserve is called hot reserve, okay, hot reserve, okay. Now another one is already 200 megawatts is giving it is, okay, and we need more power generation from this one, okay. So this will be called as spinning reserve, okay. So spinning reserve. So if particularly, okay, so if particularly they will ask about anything, okay, like what is a spinning reserve, what is a hot reserve, what is a cold reserve, okay, we need to answer this, okay. So if this is in the coal based power plant, okay, the same thing will work for this nuclear power plant and gas based this is nothing like gas based thermal power plant, okay. In India we are not using this. If you have gas and if you are using that for the power generation, make it as a gas turbine power plant, okay. So higher efficiency you will get, and otherwise you can make it thermal power plant separately and gas turbine power plant separately, or you can make it as a combination of plant also, okay, gas turbine power plant and thermal power plant, okay. That we will discuss generally in the so this gas turbine power plants, okay. 3 types will be there, okay. So the closed loop, open loop, and this combination of plants, okay. So there we have discussed about that, okay. So anyhow, so the answer for this question is pumped storage hydroelectric power plant, okay. So next question, the term surge tank is associated with the type of power plant, okay. So immediately surge tank means what will come in our mind, okay. So it will be in the hydroelectric power plant, okay. But see the options what they have given: high head hydroelectric power plant, low head hydroelectric power plant, medium head hydroelectric power plant, and thermal power plant, okay. So they have given this kind of options, okay. All 3 are hydroelectric, we can directly eliminate this, okay. So leave it now, okay. So thermal power plant we can eliminate. So generally surge tank, what is the use of this surge tank, okay. First you understand this one, then we can go what kind of head, what kind of high head power plant, otherwise low head power plant, we can understand later, okay. So surge tank, generally here we will be having a turbine, okay. Let's consider it as high head only. So we are using this Pelton wheel turbine, okay. So these buckets will be there for that, okay. We are sending water into this one. How we will send the water? So we have to use some nozzle here, okay. So this is nozzle. So I am not writing the names here. So mostly if you have understood the subjects, okay, so then only these questions you will be watching, right, okay. So that's why I am not giving any components much deeper here. So this is the nozzle. Before that nozzle we will be having a penstock, okay. So this is a penstock, okay. So cross section will be, so here it will be less and here it will be more like this, okay. So before that we will be having some tunnel here, okay. So this is called tunnel, and in between we are having this surge tank, okay. So in between we are having this surge tank, otherwise we can call it as surge house, okay. So why we are having this one? Because only one reason, okay. So for example, suddenly electrical load increase, that means more demand is available now, okay. More power generation is required. So automatically what happens? Synchronous generator, it need to produce more power output, okay. So more power output, understanding, okay. More power output it has to produce. That means automatically more discharge required. More power output means more discharge. Head we cannot change, construction is over, dam construction is already over, so head we cannot change, only discharge is in our control, okay. So we can increase the discharge, so automatically power generation will be increased here, okay. So anyhow, to increase the discharge, okay, the opening of this nozzle will be increased like this. If you open like this, all the water, more water has to come like this, right, okay. Discharge must increase means, but dam is at 1.5 kilometer, understanding, okay. If dam is at 1.5 kilometer from here, if you release immediately also, it will take 2-3 minutes to come here, okay. Immediate response we may not get, that means immediately we are not getting that water means, so what happens to the synchronous generator? It may lose the synchronism, okay, within that short time, understanding, okay. So 1 or 2 minutes means it is like a very short time for the synchronous generator and very more time for the water, Understanding? Okay, when you release the water, immediately water will not come. That's why what we'll do, we have added this extra component here, which is surge tank. So in this, generally, okay, I have given it as a big one. Okay, just observe like this. This is just like a tank only. Okay, so tank, this will be like this. Okay, one side there will be tunnel like this coming inside. Okay, so water will come inside. Okay, another side there will be, okay, so this penstock. Okay, so whenever water requirement is more, okay, so what will happen, generally because of this capillary rise, okay, so this water level will be increased a little bit higher. Okay, like this. Understanding? Okay, so then if water availability required more here, then this water will be used now before that water comes here. Okay, then automatically this will also again maintain at same level. Okay, so and whenever more water is also there, okay, so for example demand decreased, then also what will happen, this water has, this nozzle will close the openings little bit like this. Okay, so that means all the water will try to hit back, and where it will go, it will rise into this surge tank. Understanding? Okay, so in the surge tank water level will be increased. By that time we will decrease the water flow from the dam. Okay, so that means this is acting as a temporary reservoir. Okay, and this will be giving safety to this penstock, because whenever nozzle opening is increasing and decreasing like this, okay, so pressure will be building. Okay, positive and negative pressure. Okay, if it is opening, positive pressure will build. If it is closing, water wants to hit back. Okay, negative pressure will be coming. Okay, so that means whenever these things are happening on this, you observe, okay, in a pipe, if water is going in one direction, pressure is coming in opposite direction, this pipe will break easily. Okay, so you can observe that. Okay, generally in outside water pipes also same things only happening. Okay, if everyone closes at a time, okay, what happens, water will hit back, then pipes will be damaged at that time. Okay, so that's why, so instead of breaking, we have produced this surge tank. Okay, so very near to this powerhouse. Okay, so this area is called powerhouse. Wherever turbine and generator is there, that is called powerhouse. Okay, power generating house, otherwise powerhouse it is. Okay, and this is nothing but a dam. Okay, so from the dam to the powerhouse, if more distance is there, why generally we need more distance, we need head. Okay, if you need head, then we need to produce little bit of more distance. Okay, otherwise if naturally it is available, okay, like for example, so one valley is there. Okay, so valley is there, so automatically head will be available. Okay, so everywhere it is not possible. That's why generally high head plants, so this will be like 1.5 kilometer like that. Okay, so that's why, so we need to have surge tank. So if this surge tank is very far from this powerhouse, then also same problem will come. Okay, so dam only is there at very far, right? So that's why surge tank should not be placed far away from this surge house, from this powerhouse. So this surge tank must be placed near to this powerhouse. Understanding? Then only pressure release and positive and negative pressures easily it will handle. Okay, so this whatever water is coming on this penstock in positive direction and negative direction also, that means it is hitting back. Okay, so this kind of effect is called, okay, water hammer effect. Okay, because of that, so this may break. Okay, so this is called penstock may break. So water hammer effect is there on the penstock. That water hammer effect can be avoided by using this surge tank. Okay, so that's what the complete concept of this one. Okay, in low head plant, not required this surge house. Okay, low head plant generally it will be very near only. Okay, so high head plant only very far from this one. Okay, so that's why answer for this question is high head plant. Okay, so high head hydroelectric power plant. Okay, so that's what the answer for this question. So you observe, okay, so the components, all these things from this hydroelectric power plant. Okay, so in our next session, okay, so we'll come up with different questions from transmission and distribution. So mostly like, okay, so I have added thermal power plant and this hydroelectric power plant as the major portions. Okay, so but you need to solve engineering services and similarly GENCO-TRANSCO previous year questions. Okay, so for this AEE examinations. Okay, so anyhow, so you just concentrate more on the GENCO-TRANSCO previous year questions first, then you go for the engineering services questions. Okay, that will be better option if you have less time. Okay, so anyhow, in our next session we will meet with different questions. Thank you so much.